Hi, I'm Antony Darby. This is one of a series of videos looking at the analysis of truss structures.
We have previously looked at the qualitative behaviour of pin-jointed trusses. This video will describe how we can quantify forces in a truss for given loads. Our qualitative understanding will allow us to check whether values are reasonable. We will make use of our three equations of equilibrium. The sum of the moments equals 0, the sum of the horizontal forces equals 0, and the sum of the vertical forces equals 0. These three equations allow us to calculate reaction forces and member forces. Let's look at a simple two-member truss. First, let's look at the reactions. Where we have a single member coming into a support, the reaction must be in the direction of the member. However, we normally draw diagonal reactions as horizontal and vertical components of force. So for this example, we have a horizontal reaction at the bottom and a horizontal and vertical reaction at the top. We can now use our equations of equilibrium to evaluate these reaction forces. Using vertical equilibrium, the downwards 10 kN force must be equilibrated with the vertical reaction force. These two forces cause the structure to want to rotate, and this rotation is resisted by the horizontal reaction forces. Using horizontal equilibrium, we know that the two horizontal reactions must be equal and opposite. Using moment equilibrium, we can evaluate these two reactions. We can take moments about any convenient point, usually about one of the unknown reactions. Let's take moments about the bottom reaction point. Therefore, in our joint, the vertical 10 kN load is equal and opposite. So these are our final reactions. Now we can calculate the member forces. We can do this by looking at equilibrium at a particular joint. This is called the method of joints. Let's consider the joint where the load is applied. We have two unknown forces, F1 and F2. We know for vertical equilibrium that the vertical forces must be equal and opposite. The force F1 has a vertical component of force and a horizontal component of force. Therefore, in our joint, the vertical 10 kN load is equal and opposite to the vertical component of F1. Considering horizontal equilibrium, we have a horizontal force F2 and a horizontal component of F1, which must be in equilibrium. So our forces and reactions in our truss are as shown here. Let's consider another example. Here we have a truss with two loads. The truss angles are all 60 degrees. The left-hand support is a roller, so it can only provide a vertical reaction. The right-hand support provides both vertical and horizontal reactions. Using horizontal equilibrium, the horizontal reaction must be equal to 5 kilonewtons. To calculate the vertical reactions, we will first take moments about the left-hand support. This gives us the right-hand vertical reaction. We then use vertical equilibrium to calculate the left-hand reaction. So we have now calculated all the reactions and can move on to calculate the member forces. We can work out whether the members are in tension or compression, and then use the method of joints to work out the member forces. We will first examine the joint at the left-hand support. We use vertical equilibrium to equate the vertical component of the force F1 with the vertical reaction force. We then use horizontal equilibrium to equate the horizontal component of F1 with the horizontal force F2. We've now calculated the forces in both members attached to the left-hand joint. We can now move on to look at a second joint. Again, we start with vertical equilibrium to equate the vertical component of force F4 with the vertical component of the force F1, which we have just calculated as 3.27 kilonewtons. We use horizontal equilibrium to equate the horizontal force F3 with the horizontal components of forces F4 and F1. We repeat this process as many times as necessary in order to calculate the forces in all members of the truss.